Okay, I believe 14 is the last problem. Let me just check. Yeah, it's the last problem. What's the problem being the last problem? It's not an easy one. All right. I'm not going to say it's nightmarish, but it took me effort to get through it. Right. This is typical of Wells problem sets. Initially they start off really simple. It's so true of most math books. First question is pretty simple. Not always, by the way. Like I notice Wells can really throw a zinger in the beginning, but towards the end they can be brutal. What makes this more difficult than the others is the parameter m and n. All right, so I just want to read through the solution for you. It says just subtract the two equations and you'll get an equation where the zero product rule nicely applies. So I did it. I did x squared minus y squared, mx minus ny minus nx plus my. That's clearly written over here. And then what I did was I rearranged it. Now part of rearranging it is to factor it. And I'll point out what I mean by that. The left-hand side factors x plus y, x minus y. And the right-hand side, it looks like it's going to factor if I rearrange it. So I'd say m, and then I'd have x plus y. And then I'd have minus n, and that looks like x plus y again. So what is this side factor to? X plus y times m minus n. And I bring it to one side so I can use the zero product rule. And what would you get? You get this line over here. Does that take work to get there? Yeah, it does. It takes work to get there. And then I guess I should write that down for you because I know some steps are missing here. Factor out x plus y. And we left off with x minus y minus m plus n equals 0. That's how they got that over there. All right? So my question is, what do you do about that? It can be tough. There's no doubt about it. It can be tough. So the first thing to do is I look at the first factor. And that has to be 0, which means x equals minus y. That's written over here. And then what I do, I substitute that in to the first equation. Someone says, why'd you choose the first? I don't know. It's the first one. You could have chosen the second one, whatever you want to choose. So into the first equation, what do? Where I saw x, well, let me remind you, the first equation is x squared. Oops, sorry about that. Is x squared equals mx minus ny. X squared mx minus ny. All right? I just plug it in. What's x? It's minus y. So I just plug it in there. Plugged it in there. By the way, what I mean by that is over here. What do you get? Y squared, and then you get minus y times n plus 1. I want to go through that with you. Let me get my eraser out, because the passes are past now. I get rid of this over here. I understand that part there. And this is how you study the key, by the way. All right? So, let's put that down for you. What do you get? Y squared plus y m plus n equals 0. Factor a y out, you get y plus m plus n equals 0. So y could be 0. Well, if y is 0, what's x? It's going to be 0. What else could be y be? It could be minus m minus n. That would make that 0 as well. That's written over there. What do I do to get the x? Take the opposite of it, m plus n. Works beautifully. It really does. All right, let me get my eraser out. I'm done with case A. What I mean by that, I'm convinced of this fact at this point. Now, granted, if you're really retentive, you can check it in the original system. Now, what am I going to do now is, maybe we should talk about that 0, 0. It's a trivial solution, by the way. The other one a little more complicated. We can check it, though. The next one I got to substitute in there, this over here. And I'm going to say here, x equals y plus m minus n. And I got to substitute into the first equation. Oh, what's the first equation, you ask? It's x squared. I got to remind myself. mx ny. Yep. Plug it in. It's tough though, right? So you got to plug this in here and here. And what do you get? You get this. Again, this gets a little nasty. All right, a little bit nasty. And the reason for that, I can't say the reason for anything. How do you use a quadratic formula, though? And that's what made it so nasty. All right, but I'm kind of clear that if you did a little work here, you get this over here. And what's the coefficient of the square term? The a would be 1. The b is the coefficient on the linear term, which is m minus n. And the constant here is going to be n squared minus mn. So, I basically just plugged it into the quadratic formula. And let's take a look at that. So you get the opposite of b on top, which is n minus m, plus or minus m minus n squared. 4, a is 1, and that's going to be c. What goes on bottom 2. I had to manipulate work. I had to manipulate more. I guess there's not much work there, is there? Let me see if I have any differences there. No, there's no work there. They just wrote the same thing down twice. I don't know why they did. Oh, I'm sorry. They didn't write the same thing twice. I apologize. They wrote the y down. That's done. And now what they did was they got the x. And you're right. This is work. I should read. They got the x. How did they get the x? So I don't know how they got the x. They had to plug it back in somewhere. And what are we using here? We're using this. So you'd have to do the y plus the m minus n, and you should get what we get over here. It's not easy, though, and I know that. It's not easy. All right? And then I wrote my ordered pair down for you, and I got the combinations over here. Okay. I consider this to be a tough problem, but it's worth the work. It's worth the work. Now, again, did I do all the work? I did, every detail. Did I use a lot of paper and pencil? Of course I did. But I got the end of it. All right, so let me remind you who I am. My name is Ron Bannon. My email address, by the way, Ron Bannon's right there. Bannon, that's B as in boy, the @ symbol, NNON.US. Thank you for paying attention.